Hi, Math 2 Enhanced. So this is page 5 of our packet. And we are going to be factoring when our leading coefficient is greater than 1. In other words, my a is not equal to 1. And you can see in the rest of the problems on the page that none of the a values that you're looking at are 1. So what are the steps for success here? We're going to begin the same way we did for the trinomials when a was 1. We're going to have our a, c on top, and our side numbers are going to multiply to that number. We're going to have our b on the bottom, and our side numbers are going to add to that. So step 2 is we think of the side numbers for that particular diamond or x problem. So next, we take our side numbers, and they are not our answer. There's no shortcut here. Instead, we rewrite the trinomial as a 4-term polynomial with our side numbers. So for instance, a trinomial has 3 terms, as all the problems on this page have 3 terms. But we're going to actually turn them into a 4-term polynomial. That's so that you and I can factor by grouping. We need 4 terms, so we can underline the first 2 and underline the last 2. And then again, if we want to check our answer, we always can do that by multiplying our answer by either FOIL or box method to see if we get the original problem back. So let's take a look at the first one. I create my diamond, and at the top I write a times b. In this case, that's negative 18. That's the number my side numbers will multiply to. And at the bottom, I have my b, which is 3, and that's the number that my side numbers are going to add to. So I'm thinking of my combinations, and I'm thinking of 3 and 6, and in order for my 3 to be positive, the 6 has to be the positive. So I have negative 3 and positive 6, and you can write them in any order. So now those are not my answers. Do not put those in factored form. You're going to have the wrong answer. I rewrite my trinomial as a 4-term polynomial using the negative 3 and the positive 6. So I'm going to rewrite the 2x squared. Let me go grab my blue pen. Now I'm going to write minus 3x plus 6x. And you can put the side numbers in any order you want. You could have wrote the 6x first and the minus 3x second. Our work will look a little bit different on the next line, but we will get the same answers. And let me go back to red, and then the minus 9. So if you notice, what I did there is I changed this 3x in the middle. It's been rewritten as my 2 side numbers of minus 3x plus 6x, which is equal to 3x. My polynomial is still the exact same polynomial, but now it's written with 4 terms, and I can use my factor by grouping skills here. So I'm going to underline the first 2 and the last 2. I'm going to factor out my GCF, which would be x. So I get 2x minus 3. Here it would be 3, so I have 2x minus 3 again. And I'm basically done. I take what is the same, and I write it in front. And I take what is left over, and I write it behind. And this would be my answer. This is 2x squared plus 3x minus 9 in factored form. So let's take a look at 42. So 42, before you start doing this one, don't forget, and I'm going to write this at the top of our page, don't forget to look for GCF. Because it always makes my work easier when I have smaller numbers. So in this particular case, I notice they're all even. I can factor out a 2. So what do I do with that 2? It just comes out in front. But this time, since factor by grouping uses some parentheses, I'm going to put a big bracket there. And that just keeps everything separate from my 2. My 2 is just going to sit out in front. It's not going to go anywhere. It's not going to do anything. It's just going to be out in front. So let's factor a 2 out of everything. 4x squared divided by 2 is 2x squared. 6x divided by 2 is 3x, and negative 18 divided by 2 is minus 9. So now I do my problem. I create my diamond. Negative 9 times 2 is negative 18. And then underneath, I've got my positive 3. It's actually the same problem we just did. But let's keep going, you guys. So my numbers are 6 and negative 3 this time. I'll put my 6 on the left and my negative 3 on the right, so you see that we get the same exact answer. So I have my 2 in front. I'm not doing anything with it. It's going to stay there. I'm now going to rewrite my trinomial. I'm going to have my 2x squared in front. I'm going to have my minus 9 in the back. However, I'm going to use my two numbers from the side, my 6 and my negative 3. I'm going to write my positive 6x and my negative 3x here. Again, what those are simply another way of writing this plus 3. I did that way to make a 4-term polynomial because I can factor that. So I'm going to factor the first two and the last two. My GCF of 2 just stays in front. And then when I factor it, my greatest common factor out of my first two terms, that would be 2x. And I have an x plus 3 left over. Now the minus 3x minus 9, their GCF is what? Negative 3. So let's factor out a negative 3. I get a positive x plus 3 when I factor out a negative 3. And now my problem ends the same way as all factor by grouping. I'm going to take what's the same and pull it out in front. Don't forget the 2 that's in front, that GCF. So now I have my x plus 3, and I throw my leftovers in, 2x minus 3. And I often have students wonder what happened to my brackets. Nothing. But I don't really need the brackets anymore. There's only multiplication here. When I pull the x plus 3 in front and I put the 2x minus 3 in another set of parentheses, there's no reason to have brackets anymore. You can, but they aren't useful. So now there's a trick to 43. Look at it for a moment and see if you can notice what's different about it from 41 and 42. I hope you're noticing this negative in front. That negative in front isn't a problem, other than sometimes our work is easier without it. So my advice is to factor out a negative 1 to make your work, quote unquote, easier. So in this problem, I'm going to use my brackets again, and I'm going to factor out this negative 1. I'm going to divide every single term by negative 1. Be careful you divide every single term by negative 1, or you're going to get the wrong answer. So negative 3n my squared divided by negative 1 is positive. The plus 8n divided by negative 1 is a negative 8n. And negative 4 divided by negative 4, or negative 1, is a plus 4. So this is my new problem, and my a is not negative, and some people feel like that just makes their work a little clearer or easier. Okay, so let's start out with our diamond. Our AC is on top, that's 12. Our B is on the bottom, that's negative 8. And so you're considering step 2, you're thinking. I hope you're thinking about 2 and 6. I hope you realize it's a negative 2 and a negative 6, so that my 8's negative. And now I'm going to rewrite my trinomial as 4 terms. So I've got my negative 1 in front. I keep my 3n squared. I keep the plus 4. But I'm going to rewrite the negative 8n as minus 2n minus 6n. Technically, it doesn't matter what order I write them in. I'm going to end up with the same answer in the end. So I just took my side numbers, my negative 2 and my negative 6, and I put them in either order is fine, instead of my negative 8n. So back to factoring by grouping, I underline the first two and the last two, and my negative 1 is just out in front. So 3n squared minus 2n has a GCF of n, and I've got a 3n minus 2 left over. Now careful here, this is a problem where to get my parentheses to be the same, I'm going to factor out a 2, a negative 2. So this is a negative 2, and when I divide a negative 6n by negative 2, I get a positive 3n, and 4 divided by negative 2 is a negative 2, and you'll notice that my parentheses are the same. So this is where I'm going to drop my brackets because they're just not useful anymore. You can keep them, but you don't need them. So -1, I'm going to pull my 3n minus 2 out in front and put my leftovers n minus 2 behind, or order doesn't matter there. And that would be my answer. So the rest of the page are problems that if you were in class, we're going to work on. I just want to mention for those of you that were absent and you're watching this at home, be careful on 47. This is one I recommend pulling out the GCF first because your numbers get smaller. It gets a little easier. Let me move down the page. I recommend on 49 and also on 50 to factor out that -1 because the math again gets easier. And there's no trick to 52, but there is something I want you to notice. So why don't we take a quick look at 52 together? So first of all, there's a negative out in front. So let's factor out my negative. So my -1 leaves me positive x squared. All my signs are flipping when I divide by -1. Minus 5x minus 6. So I'm going to now create my diamond. And on top I have a -6. And on the bottom I have a -1. And so I'm thinking, I'm sorry, -5. I'm thinking of numbers that work there. And I think of +1 and -6. Now you might notice that this has an A of 1. This is more like the problems on page 3, but I'm going to do this the way I did the problems on this page. I want to show you that this method always works, even on the easier problems where A is 1. So let's try it. I have my -1 in front, and then inside I'm going to keep my x squared, I'm going to keep my -6, but again, I'm going to rewrite my -5 using my two numbers from the side, and I can put them into my problem in any order. So I'm going to do I didn't mean to be on the highlighter. I'm going to do my +1x or plus x minus 6x. So here we go. I'm going to underline the first two and the last two. And so I have my -1 out in front. X squared and x. Looks like the GCF is what? X. So I get x plus 1 left over. And -6x and -6. To get it to match, to get my parentheses to be the same, I'm going to divide out a -6. And I get my x plus 1. So now these are the same. So I'm ready to pull them out in front. And I get -1 times x plus 1 times x minus 6, my leftovers. And a couple things I want to mention. You'll notice that my side numbers were -6 and +1. Those are the two numbers that are in my parentheses because this is an easier factor problem because my A was 1. It's like the ones we learned to do on page 3. But if you're feeling like you're getting a lot of methods and you're confusing them, you could not do the shortcut on page 3. You could always do every trinomial factor by grouping like they are on this page. And that might be easier for some people. I also want to mention that when you factor out a -1, you don't have to write the 1. So you may see some people that just write a negative in front, and it's the same thing as writing the 1. Okay, so let's take a look at the next page. On this page, we have two more types of factoring. Both are a pattern, the difference of two squares and the sum and difference of two cubes. So first of all, the difference of two squares, I abbreviate this as dots. The D, the O, the T, and the S. It's dots. Dots are easy. Dots are fun. We like dots. So difference of two squares, let's make this easy. Let's make this fun. So this particular situation only works when it's the difference. Well, what about the sum of two squares? It doesn't work, and I'll show you why in a moment. So when I do the difference of two squares, the answer in factored form is always this pattern. So the first thing we do is we figure out the square root of our first term. and we figure out the square root of our second term. So once we do that, we write our parentheses, a plus minus, and either order is fine. And inside here, our first term is the square root of the first term, and our second term will be the square root of our second term. And a note, of course you can check this by multiplication, but I wanted to make a note, you cannot factor sum of two squares this way. It doesn't work, makes no sense. I'll show you why in a moment. But let's take a look at these. Let's first do, let's look at 54. So on 54, let's take the square root of the first term. So the square root of 25 is 5, and the square root of x squared is x. So I know the square root is 5x. 5x times 5x would give me 25x back. And I'm going to ignore the negative, completely ignore it. And I'm going to do the square root of 121, and that's 11. 11 times 11 is 121, completely ignoring the negative here. And so my answer is the sum and difference of my square roots, like in step 2. So I'm going to write the sum of my square roots and the difference of my square roots. This is my answer. You could put them in either order. You could have the 5x minus 11 first if you want, and the 5x plus 11 second. And the reason why this always works is the plus minus. Let's take a look at checking this answer. I'm just going to write up to the side up here. I've got the 5x plus 11 times the 5x minus 11. So foil or box, whatever is your preference. I'll do this with foil because I'm lacking room here. So when I multiply the first, the 5x times 5x, I get 25x squared. When I multiply the inner and outer terms, I have a positive 11 times 5x, which is plus 55x. When I multiply those outer terms, I have a negative 11 times 5x, which is minus 55x. And plus 11 times negative 11 is going to give me a negative 121. So this inner and outer term are always going to be canceling because of the plus minus in my parentheses. So I'm left with then 25x squared minus 121. That's why this method works. So let's take a look at 56. At first, 56 does not look like dots. It does not look like the difference of two squares. But remember, we always, let me grab my yellow highlighter and go back to the top, we always have to look for that GCF. If I factor out my GCF, usually my numbers get easier. And when I do that here, the GCF is 2, and I would have 4x squared minus 9. Once I do that, I can see my difference of two squares inside my problem. 4x squared is perfect square, 9 is a perfect square, so I can do this then using dots. So I'm going to take the square root of my first term. Square root of 4 is 2, the square root of x squared is x, so I got a 2x there. And I'm going to do the square root of 9, which is 3. I'm not concerned with the negative. Let me go back to my red marker. So now the 2, the GCF, that just stays in front. It doesn't go anywhere, it doesn't do anything. And now I'm going to put my 2x plus 3, or you could do the minus, it doesn't matter, and the 2x minus 3 into my parentheses, and I am done. So number 57 is a problem. When you look at it, it looks like it might be something, because it is the sum of two squares. It actually isn't. I can factor out a GCF here. They both have a GCF of 9. So I get, what, 9x squared plus 4. But I can't go any further. I cannot take the square root of 9x squared and the square root of 4 and combine it in any way to factor it. It doesn't work. Just if you're thinking 3x and 2 in your head, if you do 3x plus 2 times another 3x plus 2, you're going to wind up with an inner and outer term. So in other words, the 3x times 3x would give you your 9x squared. That's looking good. But the 2 times 3x is a plus 6x. The 2 times 3x is a plus 6x. And finally, the 2 times 2 is a plus 4. Nothing is canceling. You're actually going to get 9x squared plus 12x plus 4. So that's not the 9x squared plus 4 back. So other than a GCF on 57, there was nothing else I could do there. So how about something else? The sum and difference of two cubes. So the difference of two squares up above dots you learned last year. The sum and difference of two cubes you did not. So this is the first time you've seen them, and I want you to notice the two formulas we have over here. This is the sum of two cubes, and there's a formula that it factors into. It factors into the sum of the cubed roots times the square of the first times the product times the square of the second. And this is the difference of two cubes. It has a minus sign. And notice that it factors into what looks to be the same formula. However, my signs are different. It factors into the difference of the cubed roots times then the square of the first plus the product plus the square of the second. So our steps for this one is the first thing you're going to do is find the cubed root of the first term. For those of you watching this at home, in the classroom I do show the students where the cubed root button is on the calculator. All our calculators have them, and that can help you if you're not sure what the cubed root of a number is. And we're going to find the cubed root of the second term. And then we're going to plug in our numbers into the correct formula. And when you're doing this, I would like you to ignore the plus or minus in the problem. We're going to concentrate on getting our signs from the formula. So we're going to use the signs in the formula. So let's take a look at let's start with number 61. So first of all, this is the sum of two cubes. So as I look at this, I'm going to be using the formula on the left. The formula on the left is for the sum of two cubes. So first step, we're going to take the cubed root of each side. So the cubed root, we put a little 3 in, it's our radical. We think of it as a square root symbol, but it's a radical. We put a little 3 as an index, so I know I'm doing the cubed root. And the cubed root of 8 is 2. 2 times 2 times 2 is 8. And the cubed root of x squared is just x. The cubed root and the exponent of 3 cancel each other out. So now let's do the cubed root of my second term. So the cubed root of 27 is 3. 3 times 3 times 3 is 27. And the cubed root of y cubed, the exponent and the cubed root cancel, and I just get y. That's my a and b. The 2x is my a, the 3y is my b. The 2x came first, the 3y comes second. So now let's put it into my formula. Notice in both these formulas, there's only one minus sign. So for the sum of two cubes, the one on the left, my plus sign is in my first binomial. It is the sum of two cubes, and the plus sign's in the binomial. So I'm going to have a 2x plus 3y. Then in my trinomial, if you look up at the formula on the left, my 1 minus sign is inside my trinomial. So the first term is a squared. So 2x times 2x is 4x squared. And my next term is minus ab. So minus 2x times 3y, 2 times 3 is 6, and then times x times y. And then my last term is my b squared. In this case, that's 3y squared or 9y squared. And that's my answer to this problem. And you can multiply that out to double check it. For those of you in class, we did it in class together. And if you're watching this at home, just come to office hours or class a few minutes early if you want me to go back over using the box method to multiply a trinomial and a binomial. So now let's take a look at number 60. So this is not, as it's written, the difference of two cubes. It's not the difference of two squares. However, I do notice there's a GCF of 2. Yep, just like every other type of factoring, if I pull out those GCFs, a lot of times my work gets easier. So let's do that. Let's pull out a GCF of 2, and I have an x cubed minus 8. Now, I'm sorry, that's an x cubed. Now I can clearly see my difference of 2 cubes. I've got an x cubed minus an 8. So now let's get started. My cubed root of x cubed is x, the cubed root and the exponent, 3 cancel. My cubed root of 8 is 2. And I'm completely ignoring the minus sign in my problem because I'm going to now use my formula on the left. The formula on the left is for when I have the difference of 2 cubes. Notice that for the difference of 2 cubes, my minus sign is in the binomial. Notice for the sum of 2 cubes, I have a plus sign in my binomial. That's a helpful way to memorize these. Notice in each one, they only have one negative. So when I have my negative in the binomial, there's a plus sign in my trinomial. So here we go. So I still have my GCF of 2 in front. It doesn't go anywhere. So now I have my a minus b, so in this case it's x minus 2, times, now I have my a squared, well that's x squared, plus, using my signs for my formula, x times 2, we write that as 2x, we always put the constant in front, and then plus my b squared, well that's 2 squared, so in this case that's 4. So the final answer for this problem is 2 times x minus 2 times x squared plus 2x plus 4. Thank you very much.